Okay, welcome to R programming. So the first thing you want to do is open R, and you'll have this console, and you might also have an editor pop up here. I'm going to open the editor for the day one script by going to Open Scripts and finding my script. Here it is, day one script. So the first thing you want to do is open that script and then work through the code as we discuss it on your own. So I'm going to change these window sizes just a little bit to make this lecture a little more presentable. Okay, so now we're ready. We have our script down here and our console up here. So today's objectives are to just understand the R language. We're going to talk about running and saving R scripts and workspaces, how to use a package, and then we'll look at some common mistakes and error messages. All right, so first thing we want to make sure we're clear on is the console and editor. There is a console where code is ran, so that's this top left window, and then there is an editor where code can be typed. So I've typed out some code in advance down here in the bottom right window. You'll notice this code just magically appears up here. That's because I'm hitting Control R with my cursor on this line in the editor. So hitting Control R tells I'm hitting Control R to get this line of code run in the console. So it automatically sends it up in the console and hits enter. Nothing's really happening because I have a hashtag here, and this tells R to ignore this line of code, i.e. it's just a comment. So we're not doing much yet. I'm just wanting you to be aware of the editor and the console. I could also just type it in and hit enter or copy and paste. So for example, I could copy and I hit Control V for paste, or I could click paste, right? Or I could type some code here and hit enter. Okay, so you hit enter with code in the console. So now let's talk about how to interact with R besides just sending comments over to the console. So we have data and objects, and these are analyzed by applying functions to them. Output is saved as an object using either this less than and a dash or an equal sign. You can type the name of an object to view it. And I want to remark that R is case sensitive. So we're going to create objects by running a line of code, hit type the name of the object, and hit enter to view the object that I've created. The pseudocode that I will have throughout this course. So this is just generic code. It's not real code, but it tells you how the code we're about to discuss works. So for example, I'm going to have some function with parentheses usually, and I'm going to have input my object. I run the function and it generates output. I'm saving my output using this arrow. So now I have generated an object called my output using function, i.e. by applying function to my object. And if I wanted to see what that output looked like, I would type my output. Now I have generated output. I might want to do some further processing, so I'll apply a different function to this output that I've generated. And now I have my further processed output. So just to see this actually in action, what are the functions and objects below? So here I have 5 plus 3, so the function is just plus, and it was applied to the objects 5 and 3, and the output is 8. So above in the pseudocode, we didn't actually have this type of code. We always ran something that looked like this. We took 5 plus 3, and then we created an object. So we took 5 plus 3, the value is 8, and we created an object called x. So now x exists in my workspace, and it has value 8. So I hit x, and indeed x is a new object that has value 8. I don't have to always create an object every time I run a function. Like when I did 5 plus 3, I just printed 8 to the console. I didn't save that as an object. Similarly, if I run this line of code, x times 2, now I've just computed x times 2, and the value is 16. I didn't save it as a new object. If I wanted to save it as a new object, say y, I would need to use this line of code. Now y is an object that has value 16. Okay, so that's the main idea. Throughout our programming, it's just going to be what functions do we apply and what are the properties of the objects. So let's look at a different example below, are ages and weights of babies. So here I've just typed some ages, 1 month, 3 months, 5 months, 2 months, 11 months, 9 months, 3 months, 12 months, and 3 months. And now I've used this concatenate function, which just takes the numbers 1, 3, 5, 2, 11, and saves them as a vector. And we'll talk more about that later, but it is a function that had inputs 1, 3, 5, 2, 11, and so on. I probably want to actually save that data as an object, and I'm going to call it age. So now, instead of having to retype that data every time I want to apply some function to it, I can just apply some function to age. So here I see age indeed has these values. Same thing with weight. Here is the weight of babies. 4.4, 5.3, 7.2, and so on. If I type weight, I see that now I have this object with my weights saved. So now I can type mean of age to get 5.8. And so the value in coding this way is I don't have to retype the ages just to compute the mean. So I could have done this. Mean of the ages is concatenate 1, 3, 5, 2, 11, 9, 3, 9, 12, 3. And I get 5.8. But what if I wanted to compute next, say, the standard deviation? I would have to retype this data over every time I wanted to use it, which becomes cumbersome. And so that's why in the pseudocode, the first thing you do is you create your output and save it as an object, so you don't have to keep typing in that function every time. All right, so here I have mean, age, standard deviation, age. So what functions are used above? The main functions that were used were mean and SD, and I also used this C function, which stands for concatenate. Those are the three functions used above. Which objects below are saved? So let's run this code below. So maybe I want to compute the mean age of weight. Here I did it. I have mean age, and I saved it as value x bar. I could also just compute mean of weight, and that's 7.06. But did I actually save the mean of the weights as an object? No, I did not. There is no arrow here, so I didn't save that as a new object. So I did compute the standard deviation of age and save it as SD, because you see the arrow here. I also have n is the length of age, which just counts the number of elements in that vector age. And I can view how many there were. There were 10. Okay, so further processing output. Now I have my mean, which recall was the mean age. I've computed the standard deviation and square root of n, and I've multiplied that by 2. I've taken all of that and subtracted that from the mean, so that could be the lower limit for a confidence interval. I have an upper limit computed in a similar way, except for I added 2 standard deviations over root n to the mean. Now my lower limit is 3.23875, and my upper limit is 8.36125. Now I might even want to say, I have this lower limit and an upper limit. Let's save it as just an object called confidence interval. So I'll take that lower limit and the upper limit and use this concatenate function and save it as age.confidence interval. All right. So there was a lot of functions that we applied above. We started with just ages. We first computed the mean, then we computed the standard deviation. We saved those as x bar and sdiv. We computed the sample size, which was using length, and saved that as n. So now we have those things, and we use those to create lower limit and upper limit. The important point is that you take an object, you process it, save the processed output as a new object. That new object then gets further processed, and the output is saved. So you're building. Another function I could apply is plot. If I just apply plot of age and weights, it generates this plot here in the plotting window. All right. It's worth talking about R and RStudio. So right now, I am using the base R installation. So this is the simplest installation in a Windows machine. I just have this editor and this console, and I have a file menu with some basic stuff. You can type code notes in the editor. So as you work through homework assignments, you'll want to type code that you want to keep in an editor and save it. And I've been running code in the console by hitting return or hitting Control R from the editor, as I've mentioned. So there is also an app called RStudio. So here's the icon. It looks something like this. If I open RStudio, you'll see it has also an editor. Here is the R console where code is ran. It has an editor, and it has some other information here. So it has an editor and a console, just like the base R installation, plus some additional features and bells and whistles. So code in RStudio is ran by hitting return if you typed the code into the console, or hit Control Enter from the editor. So which should you use, RStudio versus base? In most cases, it doesn't really matter. I would say if you've never used R before, start with the base, and then when you get more comfortable, use RStudio. Sometimes I think the bells and whistles can be a little bit distracting, but useful later when you get more comfortable. So you will be required to use functions like ls, getwd, and help, which will help you learn about what's going on in the background of R by typing functions into the console from the base. Some of that stuff is presented in RStudio, so please make sure that you still understand how to use all of the code that we run in these lecture videos in the base installation. Getting help with R. A lot of help is available in the help files. The first step when we go through a lecture video is always to read the help files. So most lecture videos will amount to, here is some functions, here's how you use them. Step 2, here's some more functions, here's how you use them. So I will go through those, but the first thing you want to do is always read the help file for the function. As you get more familiar with what's going on with R, those will start making more and more sense, and pretty soon that's all you'll need to do is figure out what the function is and read the help file. There's also a lot of help at the R website. I'd encourage you to go to there, and on the left you'll see Getting Help link. That's a good place to start, but there is entire R manuals at the R website as well, and a huge online community for R help. Be a little bit careful about just Googling how to do something in R, because there are, as we'll see, thousands of obscure packages and very odd ways to write code that will work but won't help you learn R. All right, so for example, suppose on day 1, which is today, we want to learn how to use the mean function in a little bit more detail. So the first thing you would want to do is run help of mean. And if you run help of mean, you can get some information. It'll give you a generic description. It tells you it's in the base package, which we'll talk about in a little bit. It gives you a generic description that says it's a function for computing the possibly trimmed arithmetic mean. And it'll say a usage up here, which gives you an example of how you use it. You type mean of x. What is x? X is an R object. And then there's going to be all of these other inputs that you can pass to the main function, like trim, NARM equals false, and many others. So it will say, here's how you use it. Here's how the arguments should be used. So it will say x. So I'm going to type mean of x. What is x? It tells you what it is here. What is trim? It tells you what it is here. It's a fraction from 0 to 0.5, representing the proportion of observations to be trimmed from each end of x before the mean is computed. So now I could read this help file without ever being told what the trim function is anywhere else and figure that out. Okay, so now I can compute the mean of weights, but trim 25% from each tail. You'll see that if I don't run trim is equal to 25, it just computes the mean of the weights. What's the difference here? I didn't give it a second argument here. So in the first one I inputted weight and trim, and this time I just inputted weight. You'll see that it has a default value, trim is equal to 0. So most functions you'll have to input at least one thing, but oftentimes not more than one thing. If you leave the other inputs blank, it has a default value that it will use that it thinks is the right default value. So, question, what type of object is the CO2 data below? So the first thing I might do is run help of CO2. And CO2 data frame has 84 rows and 5 columns. So this tells us that this is in the package data sets and that it's a data frame. And we'll learn more about what data frames are a little later. To see other data sets that are already installed in R, when you install it, you just type data and you can see that I have all of these different data sets, like formaldehyde with a very short description. I could type help of that guy. Let's look at Nile, help of Nile, flow of the river Nile. And I can get a description of it. Over here. Okay. All right, so I learned what the CO2 data is. I learned how to find data sets. I might just try to plot the CO2 data here. There's also another data set called lowercase CO2. So that's an entirely different data set. So this is a good opportunity to point out that R is case sensitive. All right, our workspace. The workspace refers to your R environment with all of your saved objects. This is altogether different than your history. So there's a history in a workspace. History is just the history of commands that you ran. So the last 3 lines of code are notes, and then this line, this commented line, and this commented line. So this represents my history, but no objects were created when I ran this code. So that's different than the workspace. The workspace is a list of your created objects. So the first thing I would recommend is to keep your workspace clean and organized. You can have a separate workspace for each day of class. I do. And there's also something called a working directory. This is where R is working from. So R is installed and it's doing all of these operations, and there is a default address where R is working from, called your working directory. All right, so some pseudocode that we want to look at. We're going to run this function rm, which will delete objects. ls will list the objects in your workspace, and set and get wd, set your working directory and get your working directory, and history will show you what the last n lines of code that you ran were. So let's run get wd. This tells me I'm currently working from this address. So my working directory right now is in my OneDrive folder at Oklahoma State. I can change this to my H drive. Now my working directory is in Windows, SAS, and R day one. Now when I run get working directory, it tells me this is now where R is operating from. So that will be really important when we go to import data sets later. Save image. I'm saving my image as dirty workspace .r data. Now I don't have to type this whole address in. Also, just so you know, I'm hitting the up arrow and it will give me the last line of code ran, so I don't have to retype. I can also just do save image dirty workspace.r data, and it will use my working directory and save my image there. So it will automatically insert this part of the address ahead of it. That's why working directory is important. Okay, so I've saved my image. Now let's look at this workspace that I've saved. I have all of this stuff in here. Remember, I computed age, I computed weight, I computed X bar, and I computed Y and some other stuff. Some of the stuff I didn't compute, so this is just from a while ago when I had created these objects in R. So I want to keep my working directory or my workspace clean. So maybe I decide I don't want age. I don't want age.ci in my workspace, so I'll just use this rm function and it will delete them. Okay, so now when I run ls, now you'll see I no longer have age and age.confidence interval in my working directory. The rest of the stuff is still there. So I would recommend before you start each homework assignment or before you start a new project that you run this line of code. This is going to remove everything in your working directory. So just in case you open R and there's a bunch of garbage in there, you can delete it all and start from a clean workspace. And so now you'll see after I ran this code, there's nothing in my workspace. This is another way for R to tell you that it's empty. So how would I save my workspace? I could do save.image again, and I can type this entire address, or I can just type, since I've set my working directory there already, I can just type this. I don't have to list the whole address. So I've saved my empty workspace as something called empty workspace. And you'll see I have nothing in my workspace. Now what happens if I do load? This is going to load that workspace that had all of those objects in it that I saved as dirty workspace. And so I could also have ran this line of code. I don't need to type the whole address again. And now what's going to happen? All of that stuff is back. So if you want to work on a project for a while and you want to be able to easily access some objects that you've created, maybe you've generated some data, done some analysis, and saved some analysis as some objects, this is a useful trick. What about if I just run history of 5? This is not anything but the last 5 lines of code that I ran, plus this code history of 5. So all of this stuff, it's important that you be able to use code when you need to in case you're doing some scripting, but if it's available in the base R file menu, I think it's okay for you to focus on using the file menu. So for example, all I need to do is go to the file menu and load workspace. So file, you have to click on the console. If I'm clicked here, the file menu is going to have things that I might use for the editor. Click on the console, and then you can load workspace, and here is my dirty workspace. And it just ran this line of code for me. So just so you understand, whenever I do anything from the file menu, it's going to run some code. And earlier when I was talking about R versus RStudio, you do need to know RStudio has more built-in codes in the file menu and other things for you as well. So you still need to know how to run code just in case you're ever scripting or need to run code from or do things from a command line. Okay. So as I mentioned, I've loaded that workspace using the file menu, and now I have all of my objects, and I again now have a messy workspace. All right, plots and scripts. So note you can call and run scripts using source. You can generate PDFs, PNG files, and many others using different functions. You have to always run dev.auth to generate the plots. So whenever you run one of these lines of code, it just opens a PDF writer, for example, and starts writing. And it doesn't get completed until you run dev.auth. Okay, so pseudocode, for example, I might run source, and I have some other code that I've ran. Instead of copying and pasting a whole bunch of code, I can just run source, and it will go and copy and paste that code essentially into the editor, or into the console, excuse me. I can also run PDF. This is a function that will open a PDF writer, save it as a file called myplot.pdf, and then I run some commands to generate a plot, and then I turn that device off, and now I have a plot. So let's look at an example. So day 1 script 2.r, I'm just going to run source. This is going to go get this file and run it. Nothing seemed to happen. If I run print.eval equals true, it will give me what objects were created as well in this source function. So what was that? This is a script. So essentially, when you install a package, this is what this is. It's just a bunch of scripts that get ran. So you'll notice here, this day 1 script 2, I just have 2 lines of code, mean of concatenate 2, 3, 4, and then I've created this object called x2, which should just be 13, have value 13 here, right? So I could have went and copied and pasted this code, okay? But instead, I just ran source, and it ran that code for me. And so now, because I've ran source, so let's do this again. I'm going to remove x2. So now there is no x2 in my workspace. I'm not going to run this code directly. I'm just going to run day 1 script 2 source. Now what do you notice? x2 is there. It went and ran that code. Okay, so if you have a bunch of complicated functions, you can save them in a file and just run source as you get more advanced. The PDF, remember I run PDF. Here's the name of my PDF. And now PDF Maker is open. I'm going to run plot, CO2. I'm going to add a horizontal line, and I'm going to turn the device off. So instead of making a plot directly in R, it never even opened the plot window. And what did that plot? It made this plot. And so I'll just show you so you can verify that it's doing that. Keep your eye over here. So I ran this line of code. Day 1 plots was created, right? Now it's there. So let's do it one more time. Run that code. You can see indeed it made this plot. Um, what does it look like? It looks like this. So again, I could have just ran plot CO2 to generate this plot and AB line. And then file, save as PDF. Also an option. I just want you to be a little bit better at just doing things with lines of code and not relying on file menus too much. All right, packages. You're currently using the base package of basic functions. There are many, many other packages already installed that just need loaded. And then there are many more advanced packages that can be installed and then loaded. But you can go to install packages. It'll ask you to select a crayon mirror. All of them should work. And then you have all of these packages here you can scroll through. So there's a lot to scroll through. If you already know the name of your package, it might save you some time just to use some code. Once you've installed your package, then you'll have to load the package. So every R session you have to load your packages. You only have to ever install it once. Okay. Now, if you go to this website, you'll see that there are 50 to 100 new packages added each day. So there are thousands, millions of packages. So be leery about using an obscure, untested package. So the nice thing about R is that it's free. One of the issues with R is that anybody can write a package with very little oversight. So there's no guarantee that a package that you install works or does what you think it's doing. The base package is pretty safe, and so in this course we try to stick to the base package as much as possible. So let's look at how to do this. Library of mass. This package is one of these that is already installed. And I can learn more about it by running help package equals mass, and there's a help file there. You'll see that it's the modern applied, well, you'll see some help stuff here. All the functions that come with the mass package. Let's not get into the details. I can even run citation of the mass package, and it'll give me a BibTeX file here for those of you that use BibTeX or LaTeX. Here's another one. ggplot package needs installed. It will not, you won't be able to load it initially. You'll have to install it first. It's not in the base. Now I can run library of ggplot. Okay. So just to show you, give you a preview of ggplot. Don't worry about how to use this function. It is a little bit more complex. But for example, once I've loaded the ggplot package, now I have this function ggplot that can be used. If I hadn't have installed and loaded the ggplot package, I would have got an error message here. Okay, so I created this plot. All right, let's just talk about some common mistakes in error message. So the first thing you want to do is you can name an object when you create it, anything you want. I've named this object, my object, with a long name that might have a typo, and saved it, and it now has value 5. So rather than typing 5, I can type my object with a long name that might have a typo. And I can take that object and multiply it by 5 and get 25. And I get this error message, my object with a long name that might have a typo is not found. So what is the issue there? You'll notice this line of code works just fine. There's just a capital O. So I've got a slight typo in my object. R doesn't know that you meant to capitalize this, and it needs it to be capitalized since R is case sensitive. So this programming language is not that smart to try to know what it thinks you want it to do. You have to tell it exactly. Another common mistake, you type mean of these numbers, concatenate 1, 2, 3, 4. I have this plus symbol. And so now every time I hit enter, I still have plus, plus, plus. What's going on? R is waiting for another closed parentheses. I have open parentheses, only one closed parentheses. So I would have to type this. Or if you're not sure where you're missing your closed parentheses, just hit stop. What's the issue here? I've typed mean of RAOD, not ROAD or ROAD. And now I get a warning message. So what's the issue now? ROAD is indeed a data set that exists in R. So there's, I didn't try to find an object that didn't exist. The issue is it gives me this warning message. Argument is non-numeric or large or logical, returning NA. So we haven't learned about what that means yet, but you get this warning message. It basically means you can't just apply the mean function to anything. It has to be a number. So this was a data set that had other values to it besides just numbers, and so R didn't know what to do. What's another common mistake? Most times when you use a function, you'll need to at least input a vector. Here I have, suppose I wanted to compute the standard deviation of the numbers 1, 2, 3. It says unused argument 3. So when I run a function, it says I tried to compute standard deviation. The first input was the number 1, the second input was the number 2, the third input was the number 3. That's not what standard deviation wants. Standard deviation, if you read the help file, it says the first thing that I need to input has to be a numeric vector. So I have to do SD of a vector, not the numbers 1, 2, 3 by themselves. So I would need to create this vector with numbers 1, 2, 3, then apply SD to it. And now it works. Okay. So we just learned today we just got familiar with R today. We learned a lot of code. Don't worry about how to work with every single function. Mostly I just want you to get the big idea on how to interact with R. So we create an object, then we apply some function to further process that object, save the new object as output, apply another function to it. And so we keep processing our data over and over and over again until we get what we